Now, guys, let's have a look at the third question of the contest. The third question was the follow-up question for the question number one. What is changed are the constraints. In question number one, we have used the big of n square approach, but over here we cannot use big of n square approach since the constraints have changed. Here the constraints we can clearly see that the size of the array are now 10 raised to the power 5. So n square approach is not going to work. So we have to see one another approach. So first of all, the question is absolutely the same. Only the constraints have changed. Everything else remains the same. So I'm not explaining the question again. Now we will have a look at the particular solution. What we have to do. See, what does the question says? The question says that a pair is called good if nums1 at the index of I is divisible by nums2 at the index of j multiplied by k. So what is the condition? The condition is that nums1 at the index of I mod nums2 at the index of that particular index, whichever we are referring to, multiplied by k, this particular thing should be equals to 0. If this particular condition is being satisfied, then what we can say, that particular pair is a good pair. Then we can refer to that particular thing, right? So we cannot use big of n square approach. So what is the first thing we will do is, we will assume this nums2 multiplied by j, this jth index multiplied by k as one variable, that is x. Nums1 at the index of I mod x double equals to 0. So very first step that we will do is we will modify our nums2 array. In nums2 array, we are going to multiply each index with k. Then nums1 at the index of I mod x double equals to 0. It means what is this x? This x is the divisor of nums1 at the index of I. Yes or no? So we will calculate all the divisors for nums1 at the index of I array. And then we will see whether that divisor exists in nums2 or not. If that divisor exists in nums2, then we will add the frequency of that number in our answer. With the help of the code, it will be very much clear to you all. So let us have a look at the code first of all. Let me raise it up. See, what we did is, first of all, we have computed the size of nums1. We have computed the size of nums2. We unordered map int comma int mp. I have stored the elements of nums2 in my map. Modified elements of nums2. How I have modified the elements? By multiplying it by k. Nums2 multiplied by k. So mp at the index of nums2 at the index of I multiplied by k plus plus. So I have maintained one map for that. I have maintained one answer variable for storing the answer. Now this is the main condition. Please have a look. For int I equals to 0, I less than size 1, I plus plus. What I am doing over here is I am iterating through my nums1 array. So if check mod k double equals to 0. So see, for example, if my that particular element of the nums1 is not divisible by k, it means that particular number will also not be divisible by nums2 multiplied by k, right? So I need not to check it. So I will check only for that particular condition if it is divisible by k. So if check mod k double equals to 0, then only I will proceed further. Then I will calculate all the divisors of that particular number. So how can we calculate all the divisors of a particular number? This can easily be carried out in square root of n approach, right? So for n j equals to 1, j into j is lesser than or equal to check j plus plus. If check mod k j double equals to 0, what does it mean? J is a divisor of the check. If j is a divisor, what I'll do, answer equals to answer plus mp at the index of j. In mp, I have stored the modified elements of nums2. If check mod j double equals to 0, it means there are two divisors. J is also a divisor as well as check divided by j is also a divisor. So for checking the uniqueness of divisor, I'll check do answer equals to answer plus mp at the index of check divided by j. So I can calculate all the divisors in root n approach, and this is going to work. So what I simply did is I have stored all the elements of my nums2 in one map, modified elements of nums2. Then I have calculated all the divisors of nums1. If that particular divisor is occurring in my nums2 vector, so that then I will add it. Answer equals to answer plus mp at the index of j, where j is the divisor, and check divided by j is also a divisor. So this particular approach is going to work. If you want the dry run, what we are doing is, first of all, I have maintained one map in which we have stored the nums2 multiplied by k. It means I have stored 1 multiplied by 1, 3 multiplied by 1, and 4 multiplied by 1. After that, I will calculate all the divisors of the numbers. So what are the divisors of 1? The divisors of 1 is only 1. So I will store 1. MP at the index of 1 is also 1. So 1 will get stored in my answer. What are the divisors of 3? The divisors of 3 are 1 and 3. So MP at the index of 1 is 1, MP at the index of 3 is 1. So 2 will get stored for this particular case. And for 4, the divisors are 1, 2, and 4. So what all will get stored? MP at the index of 1 is 1, MP at the index of 4 is also 1, and MP at the index of 2 is 0. So only 2 will get stored in this particular case. To 2 plus 2 plus 1, that comes out to be 5, which will be our output. So I have solved this particular question. If the constraints are there, then we have to apply this particular approach. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.